At Knowledge Masterpiece Private School here in Almabella, we will be running the Cambridge International curriculum. Here we have a sample question from the IGCSE maths paper. Part A reads, the nth term of a sequence is n cubed minus 5. Write down the first three terms of this sequence. Okay, well, another way to say nth term is to use this notation here, Tn. That's term n or nth term. And the Tn here for us is n cubed minus 5 as given in the question. Now the key thing, if you're given the nth term, is you've to link the n here with the n over here, any n's in the expression. So what we need to do then, if we're looking for the first three terms, that's T1, T2, and T3. Well, T1 will be equal to, we're going to replace the n here with the number 1. So T1 would be 1 cubed minus 5. So you can see here what we're doing is replacing the n with the 1 because we're looking for T1. And 1 cubed is 1 by itself 3 times, which is 1, minus 5, which is negative 4. So the first term is minus 4. T2 would be equal to 2 cubed minus 5. And again, you can see what we're doing here is replacing the n with the number 2. So 2 cubed is 2 by itself 3 times. That's 2 times 2 times 2, which is 8. That is not 6, be careful for that mistake. 2 cubed is 8, minus 5 is 3. So T2, or the second term, is 3. And finally, we have T3, which will be 3 cubed minus 5. And again, replacing this time the n with the number 3. So 3 cubed is 3 times 3 times 3. Again, this is not 9. It's 3 multiplied by itself 3 times, which is 27. And 27 minus 5 is 22. So the third term is 22. Part B, here is a sequence of numbers 3, 6, 11, 18, and 27. Find an expression for the nth term of this sequence. Okay, so this time you're given the sequence and you're asked for the nth term. It's the reverse process of what we did up here. Okay, well, when we're given a sequence like this, what we need to do is see is there a common difference in the sequence. Okay, so what's the common difference from the first to the second term? Well, we're adding 3 as we go along here. From term 2 to term 3, we're adding 5. Then we're adding 7. And here we're adding 9. So you can see here this difference is changing. It's not common. So maybe there's a second difference that's constant. Because what we want is a constant common difference. So if we have a look here, from 3 to 5, that's a jump of 2. From 5 to 7, that's a jump of 2. And from 7 to 9 is also a jump of 2. So if the second difference, this is the first difference here, this is the second difference. If the second difference is constant, it's the same value, whatever that value is, well then this original sequence here is a quadratic sequence. And a quadratic sequence will have n squared involved. Okay? So the second difference implies, second difference constant implies quadratic. In other words, Tn will have an n squared term. It has to have an n squared term. Now, the coefficient of n squared, the number in front of n, will always be half of this common difference, the second common difference. The second difference here is 2, so half of 2 is 1. So the coefficient of n squared will be 1. This is always the case with a quadratic sequence. So now we have Tn is equal to 1n squared, or n squared, same thing. Okay, so now if we, these are our, if we consider these to be our n numbers here, 1, 2, 3, 4, 5. These are our n numbers. These are the positions in the sequence. So if we have a look now and work out n squared and compare it to the sequence, I'll put it above the sequence, n squared, so 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, and 5 squared would be 25. And if we now compare these numbers, the number 1 to the number 3, number 4 to 6, number 9 to 11, and so on, what is needed now to get from these red numbers, these n squared numbers, to the sequence? And what we see is each time what we need to do is add 2. If we add 2 to 1, we get 3. Add 2 to 4, we get 6, and so on. So Tn for this sequence here is actually n squared plus 2. So the answer for Tn for the sequence is n squared plus 2. There is another way you can do this, which I'll show in another video.